Hi everyone, welcome to another video, the nanomaterial synthesis by salt gel process. So this salt gel process is a wet chemical process where it uses a metal alkoxide or salts as a precursor dissolved in the solvents like water or alcohol, enabling the precise control over the particle size, purity and composition at the low temperature. So what is the empathy part in it? Why sol-gel method? You need for the bottom-up nanomaterials synthesis. So there is a demand for the uniform, homogeneous materials which cannot be attained very easily. Low temperature requirements, energy efficient processing is also a key requirement, and the ability to produce films, fibers, powder economically. So how will you define the problem? So how can we produce high purity, highly homogeneous nanostructures materials? So we have a controlled morphology using a simple low energy method. So let's explore that. So what's the idea behind it? Sol is a stable colloidal suspension. Gel, it is interconnected semi-rigid network. The transition from the sol to gel occurs via hydrolysis and condensation process. The versatile precursors choice, that is, you are choosing a metal salt or the metal alkoxide. So what is the process that is involved in this salt gel method? There's a salt formation by the hydrolysis method. Then gel is formed after the condensation and polycondensation process. Aging, that is, it gives for more time. Drying, aerogels and xerogels are formed after drying. Then it is followed by calcination and heat treatment. So the drying process can be evaporative drying, where you get the xerogel. For by supercritical drying, we get aerogels. So this is the pictorial representation of the process. You have the salt, then the salt is converted into gel by the process. When the solvent evaporates, it's formed into gel, and the gel is dried in the process. After the dry gel, they are grinded and made into a fine powder, and next is the sifting process. So what is the chemical reaction that is involved in this process? Hydrolysis. So you have a metal alkoxide with water to give the product. Then next it's followed by water condensation, that is removal of H2O, and next is the alcohol condensation, removal of alcohol from the reactants, and you get the product. So the prototype, gel to material conversion. So you have the aerogel and the xerogel that is formed. So aging strengthens the gel network, and drying part decides whether it is an aerogel or xerogel. Calcination removes organic and densifies the material. Then it goes to final shaping into films, fibers, or nanopowders, which is also required. So we will test the materials. After heat treatment, materials are evaluated for homogeneity, particle size and morphology, mechanical stability, suitability for ceramic applications. So these are the few applications of this materials that is obtained from the salt gel process. So there are various applications of the materials, that is in the synthesis and functionalization of materials, then in biocatalysis, in drug delivery systems, in biosensing process, in bioimaging process. So nano oxides like silicon dioxide, titanium oxide, zinc oxide, coating and thin films, catalysts, optical materials, then sensors and membranes. So all these things are few of the applications of the materials, that is the nanomaterials that is obtained from the sol gel process. Thanks for watching.